Now that you know what a container concept is, let's understand what a container is technically. Technically, a container is made up of images. So we have layers of stacked images on top of each other, and at the base of most of the containers, you would have a Linux-based image, which is either Alpine with a specific version, or could be some other Linux distribution. And it's important for those base images to be small. That's why most of them are actually Alpine, because that will make sure that the containers stay small in size, which is one of the advantages of using a container. So on top of the base image, you would have application image. And this is a simplified diagram. Usually you would have these intermediate images that will lead up to the actual application image that is going to run in the container. And of course, on top of that, you will have all this configuration data. So now I think it's time to dive into a practical example of how you can actually use a Docker container and how it looks like when you install it and download it and run it on your local machine. So to start with, we're going to download Docker Desktop so that we can run Docker commands on our local computer. I'm going to open a new browser window and search for Docker download. If we click the first link here, you will see a link to download the correct version for the device. I'm using macOS with an Intel chip. Here we also have downloads for Apple chip, Windows, and Linux. Just note that Linux supports Docker natively, while for Windows and Mac, you need to install Docker Desktop. I'm going to click to download the DMG file and just wait a couple of seconds or a minute for the download to complete. Once this is finished, I can just click here to open it, and I can then drag the application across my local applications folder. The application is quite large, so this may take 1 or 2 minutes. Now, if I open my applications folder, I can see the icon right here. So let's click on the Docker icon and let's open the application. Accept the conditions here. The final step is to use the default Docker settings by clicking Finish, which will allow Docker to have some local permissions. I'm going to turn off these weekly tips here, and then the Docker engine is going to start. So here you see this window, which means the Docker engine has started. This is all we need right now to run through our demo, so I'm going to close it here. If you check the taskbar, you will see the Docker icon, and if you click here, you can see the engine is running. And right here, you can click to pause or restart or quit the engine, but I'm going to leave it running so we can continue with the demo. So to give you a bit of an idea of how this works, let's head over to Docker Hub and search for PostgreSQL. So here, which is a Docker official image, I can see some of the versions. And let's say I'm looking specifically for an older version like this one. So I'm going to pull that one. So this is a Docker repository so that I can actually go ahead and pull the containers from that repository directly. And because it's a public repository, I don't have to log into it. I don't have to provide any authentication credentials or anything. I can just get started with a simple Docker command without doing or configuring anything to access Docker Hub. And if I scroll all the way down to the first example of how to run this image, you see that we have to provide a parameter to our Docker run command. So we're going to do Docker run and then provide that parameter. And what this parameter does is basically sets an environment variable inside our Docker container. And later in the section, we're going to learn in detail how that exactly works. So this -e basically stands for environment variable, and we pass the name of the environment variable equals the value of that environment variable. So it's going to be set inside the Docker container. And then we set the Postgres image name and the version that we chose. So I can provide the version like this with a colon. So as you see, the first line says unable to find image locally. So it knows that it has to go to Docker Hub and pull it from there. And the next line says pulling from library Postgres. And here you see a lot of hashes that says downloading. And this is what I mentioned earlier, which is Docker containers or any containers are made up of layers, right? You have the Linux image layer, you have the application layers, and so on. So what you see here are actually all those layers that are separately downloading from the Docker Hub on my machine, right? And the advantage of splitting those applications in layers is that actually, for example, if the image changes or I have to download a newer version of Postgres, what happens is that the layers, they're the same between those two applications. Two versions of Postgres will not be downloaded again, but only those layers that are different. So for example, now, because it is the first time, it took a little bit longer to download this one image because I don't have Postgres locally. But if I were to download the next version of Postgres image, it would take less time because some layers of that image already exist on my local machine. So now you see that it's already logging because this command that I ran here, the docker run with the container name and version, it fetches or it pulls the container, but it also starts it. So it executes the start script right away as soon as it downloads it. And here you see the output of the starting of the application. So it just gives some output about starting the server and doing some configuration stuff. And here you see database system is ready to accept connections and launcher started. So now let's open the new tab and see with docker ps command, you can actually see all the running containers. So here you see that Postgres with this specific version is running and it actually says image. So this is another important thing to understand when we're talking about containers. There are two technical terms, image and a container. And a lot of people confuse those two, I think. And there is actually a very easy distinction between the two. So image is the actual package that we saw in one of those previous slides. So the application package together with the configuration and the dependencies and all these things. This is actually the artifact that is movable around is actually the image. Container is when I pull that image on my local machine and I actually start it, so the application inside actually starts, that creates the container environment. So if it's not running, basically it's an image, it's just an artifact that's lying around. If I start it and actually run it on my machine, it is a container. So that is the distinction. So here it says the active running containers with a container ID, image that it's running from, and some entry commands that it executed and some other status information. So this means that PostgreSQL is now running on my local machine. Simple as that. If I were now to need, let's say, another version of Postgres to run at the same time on my local machine. So let's go back and let's say I want to have versions 13.10 and 14.7 both running at the same time on my machine. I would just do run Postgres and run. Again, it doesn't find it locally. And this is what I actually explained to you earlier. Because it's the same application, but with just a different version, some of the layers of the image are the same. So I don't have to fetch those again because they are already on my machine. And it just fetches the layers that are different. And this is great because it saves time and network bandwidth when uploading and downloading the images. And now you see I have Postgres 13.10 running in one terminal window and Postgres 14.7 running in another one. So I have two Postgreses with different versions running and I can actually output them here. I have both of them running and there's no conflict between those two. Like I can actually run any number of applications with different versions maybe of the same application with no problem at all. And we're gonna go through how to use those containers in your application and the port configuration and some of the other configuration stuff later in this tutorial when we do a deep dive. But this is just for you to get the first visual image of how Docker containers actually work, how they look like, and how easily you can actually start them on your local machine without having to implement a specific version of Postgres application and do all the configuration yourself.